Hello guys, in this video we're going to be going over the questions of the AMC8 1999, so let's get into it. Problem number 1 states 6(3) plus 4 minus 2 minus 1 is equal to 5. To make this statement true, the question mark between 6 and the 3 should be replaced by A divided by, B multiplied by, C addition, D subtraction, or E none of these. So first we have to simplify the left side of the equation, and doing so will leave us with plus 4 minus 2 plus 1 is equal to 5. Then we simplify this further, we get 6(3) plus 3 is equal to 5. We subtract 3 from here, and we get 2 on the right side, and you have 6(3) is equal to 2. And as you can tell by now, the answer is A divided by, because 6 divided by 3 is equal to 2. Let's move on to the next question. This is problem number 2. It says, what is the degree measure of the smaller angle formed by the hands of a clock at 10 o'clock? 10 o'clock, the small hand is pointing at 10, big hand at 12. And since they're 360 degrees in a circle, and there are only two numbers between 10 and 12, it's going to be 2/12 of 360 degrees. 2/12 can be written as 1/6, and 1/6 of 360 is 360 divided by 6, which is 60 degrees, which is question C. Now move on. Problem number 3 states, which triplet of numbers has a sum not equal to 1? So question A, it says 1/2 plus 1/3 plus 1/6 is equal to 3/6 plus 2/6 plus 1/6, as 1/2 is equal to 3/6 and 1/3 is equal to 2/6, and this equals to 1. So answer A is not our answer. Let's move on to answer choice B. Answer choice B is 2 minus 2 plus 1. This also equals to 1, as 2 and minus 2 cross out. So answer choice B is also not our answer. Let's move on to answer choice C. Answer choice C is 0.1 plus 0.3 plus 0.6. This also equals 1, as 0.1 plus 0.3 plus 0.6 is equal to 1. So answer choice C is not our answer. Answer choice D is 1.1 minus 2.1 plus 1.0. And this equals to 0, as 1.1 minus 2.1 is -1 plus 1, which is equal to 0. So our answer is D. Let's move on. Next question is problem number 4. It says, the diagram shows the miles traveled by bikers Alberto and Bourne. After 4 hours, about how many more miles has Alberto biked than Bourne? After 4 hours, Alberto has biked 60 miles. And after 4 hours, Bourne has biked 45 miles. So if we find the difference between these two, it's 15. So our answer is A, 15 miles. Let's move on to problem number 5. Problem number 5 says, a rectangular garden 60 feet long and 20 feet wide is enclosed by a fence. To make the garden larger while using the same fence, its shape is changed to a square. By how many square feet does this enlarge the garden? So the garden is like this, a rectangle, 60 feet wide, 60 feet long, and 20 feet wide. And to find the enclosed fence length, we have to find the perimeter of this rectangle. To do this, we do 20 times 2 plus 60 times 2, which is equal to 40, plus 120, which is equal to 160. And the perimeter of our rectangle is 160, and since that's made into a square, and square have equal side lengths, we divide this by 4, and we get 40. To find the difference between the area of the previous rectangle and the new square, we have to first square this to find the area of the square, and we get 1600. And the area of the previous one is 60 times 20, which is 1200. And then we subtract these two, we get 1600 minus 1200, which is 400 square feet. So our answer is D. Let's move on to the next question. Problem number 6 says, Bo, Ko, Flo, Joe, and Mo have different amounts of money. Neither Joe nor Bo has as much money as Flo. Both Bo and Ko have more money than Mo. Joe has more money than Mo, but less than Bo. Who has the least amount of money? So first we'll write it all as equations. So Joe nor Bo has as much money as Flo. So Flo has more money than Joe and Bo. Both Bo and Ko have more than Mo. So Bo has more than Mo. And Ko also has more than Mo. And then Joe has more than Mo. So Joe has more than Mo, but less than Bo. So has less than Bo. So our answer is the one which is not greater than any of the other people. So if one person has more money than another person, they're automatically crossed out. So as you can see, Flo has more money than Bo and Joe, so he's crossed out. And since Ko has more money than Mo, that he's crossed out too. And then Bo has more money than Mo, so they're crossed out too. And then Joe has more money than Mo, so they're crossed out too. And then the only one remaining is Mo, so our answer is E, Mo. Let's move on to the next question. Problem number 7. The third exit on a highway is located at milepost 40, and the 10th exit is at milepost 160. There is a service center on the highway located 3/4 of the way from the third exit to the 10th exit. At what milepost would you expect the service center? So let's create a line over here that basically tells the difference between the third exit and the 10th exit. So the third exit is at milepost 40, 10th is at milepost 160. So the length in between them is 160 minus 40, which is 120. And since they're asking us to find the distance 3/4 of the way, we find 3/4 of this, which is 90. And then we have to find the distance between this is 120. Over here is 120. And we found 3/4 of that, which is around here, is 90. So this is 90 more than the milepost at 3, the third exit. So that's 90 plus 40 is equal to 130. So our answer is E, 130. Let's move on. The next is problem 8. It says 6 squares that are colored front and back. R equals to red, B equals to blue, O equals to orange, Y equals to yellow, G equals to green, and W equals to white. They're hinged together as shown, then folded to form a cube. The face opposite the white face is. So first, we need to identify which one we can keep at the center. We can keep any of these squares at the center, but the most optimal one be either G green or Y yellow. We will use G green for this purpose, for this question. And obviously on the right side would be yellow, so this would be on the right side. And on the left side would be red, because if this was folded this way, then this would fold this way. So this would be on the right side, this would be on the left side, and in front from this perspective would be this, and behind that would be this, and on top would be this, and the bottom would be this. So across from white would be blue. So our answer is A, blue. Question number 9. 3 flower beds overlap as shown. Bed A has 500 plants, bed B has 450 plants, and bed C has 350 plants. Beds A and B share 50 plants, while beds A and C share 100. The total number of plants is. So since bed A has 500 plants and you want to keep that the same, we keep 500 here. But then bed B has 450 plants, but they overlap with bed A by 50. So if you were to count 500 plus 450, that would overcount by 50. So we subtract 50 from here. And same thing from bed C, except it's not 50 plants, it's 100 plants. So it's 350 minus 100. that would be 500 plus 400 plus 250, which is 1,150 lengths. Our answer is C. Let's move on. Problem D. A complete cycle of traffic lights takes 60 seconds. During each cycle, the light is green for 25 seconds, yellow for 5 seconds, and red for 30 seconds. At a randomly chosen time, what is the probability that the light will not be green? So the light is green for 25 seconds, so it's not green for 35 seconds. It's 35 seconds. And the total number of seconds it takes to cycle around is 60. So we put this in a fraction like this, and then we can simplify this by dividing by 5 on both sides, on the top and bottom. And doing this, we get 7 over 12. So our answer is E. Let's move on. Problem 11. Each of the 5 numbers 1, 4, 7, 10, and 13 is placed in one of the 5 squares so that the sum of the 3 numbers in the horizontal row equals the sum of the 3 numbers in the vertical column. The largest possible value for the horizontal or vertical sum is A20, B21, C22, D24, and E30. So since we want to find the largest possible value, we start from the end and work our way down. So E30, let's find possible numbers that can equal 30 in this. So the only possible value would be 13 plus 7 plus 10, which is equal to 30. Even if you were going to put 13 in the middle, then 1 plus 4 plus 13 would only equal 18, which is not 30, and they're not equal. That's why this would not be the correct answer. Now let's try 24. To make 24, we can put 13 in the middle, we can put 10 here, and we can put 1, which makes 24 on the columns. And then if we were to put the remaining numbers, 7 and 4, over here, then this would also make 24. So our answer is D, 24. Let's move on. Problem 12. The ratio of the number of games won to the number of games lost, no ties, by the middle school middies is 11 to 4. To the nearest whole percent, what percent of its games did the team lose? So out of the, say the team played 15 games, then they won 11 of them, and they lost 4 of them. So basically, they lost 4/15 of their game. And if you don't know what 4/15 would be in a decimal, then we can do long division. So it'd be 15 divided by 4 is 0. Put 0 here, and you put 2, 30, 1, 0, 0, 6, 90, 10, 0, 0, 6, and this would keep on repeating, so our answer would be 0.266 repeating. And this most corresponds to the B, 27%, because when you convert a decimal to percent, you multiply by 100, and you get 26.6 repeating percent, which is roughly equal to 27%. So let's move on to the next question. Problem number 13. It says, the average age of the 40 members of a computer science camp is 17 years. There are 20 girls, 15 boys, and 5 adults. If the average age of the girls is 15 and the average age of the boys is 16, what is the average age of the adults? So to do this, first we need to identify we need to create an equation, and we need to identify what we want to find. We want to find the average age of the adults, so that's only 5 of them. So we create the equation 20 girls times their average age, which is 15, plus 15 boys times their average age of 16, plus 5 adults, which their average age we're trying to find, so it would be X, divided by the 40 members, which is their total average age, 17. So this is the equation we want to solve. So first we do 17 times 40, which is 680. So 680 is equal to all of this. So 20 times 15 can be simplified to 300. And 15 times 16 can be simplified to 240. 225, 235, 240, yes. And then this is just stays 5x. And we can find that a common factor of 5 is here. That's why we divide by 5 during this whole thing. And we do 136, that's equal to 136. And this equal to 60. And this equal to 48. A simple way to divide by 5 is just to take out the last digit. Like, if there's 0 at the last digit, take out the last digit and multiply the other remaining digits by 2. So that's what I did. Take out the last digit, 30 times 2, 60. Take out the last digit, 24 times 2, 48. Take out the last digit, 68 times 2 is 136. So then remaining, we have 60 plus 48 plus x is equal to 136. So 60 plus 48 is 108 plus x is equal to 136. And 136 minus 108 is 28. So x is equal to 28. So our answer would be C, 28. Let's move on to the next question. Next question is, in trapezoid ABCD, the sides A, B, and CD are equal. Their perimeter of ABCD is A27, B30, C32, D34, E48. So we're given the height of the trapezoid, which is 3, and we're given the top base and the bottom base. So we're also given that AB is congruent to CD. This means that the height and this length is also equal to this height and this length, because these are both right triangles, and if the hypotenuse stays the same, then the legs also must have the same lengths. So this means that this is also 3, and if this is x, then this also is x. And to find the value of this x, we can write an equation. 2x, where since this is whole 16, and this is 8, we can write 2x plus 8 is equal to 16, which is 2x plus is equal to 8, and x is 4. So then we form a 3, 4, 5 triangle. And I know this is 3, 4, 5 because it's a Pythagorean triplet. We can also write over here, prove it. 3 squared plus 4 squared is equal to x squared. 3 squared is 9, 4 squared is 16, equals x squared, and 9 plus 16 is 25, equals x squared. And the square root of 25 is 5. So we know that the 5 is the side length over here of A, B, and CD. Now we can just add everything up to 16 plus 8 plus 5 plus 5. 5 plus 5 is 10. 16 plus 8 is 24. When we add this, we get 34. So our answer is D, 34. Let's move on to the next question. Next question is, bicycle license plates in Flatville each contain 3 letters. The first is chosen from the set CHLPR, the second from AIO, and the third from DMNT. When Flatville needs more license plates, they added 2 new letters. The new letters may both be added to one set, or one letter may be added to one set and one to another set. What is the largest possible number of additional license plates that can be made by adding 2 letters? So first we want to find the additional license plates. So we need to find the original first. And in the first letter, they're choosing out of 5. So they're 5. The next one, they're choosing out of 3. So it's times 3. The third, they're choosing out of 4. And then when we multiply this, we get 60. We'll just write 60 over here. And since they're 5 in the first, 3 in the second, 4 in the last, they say they can add 1 letter to either 2 of them or 2 letters to 1 of them. First, we need to find all the possible combinations. So all the possible combinations would first include 2 in each of them. So 2 in the first one would make 5 to 7, times 3 stays the same, times 4 stays the same. And then if 2 were added to the second one, then it'd be 5 times 4. And if 2 were added to the last one, then it would be 5 times 3 times 6. So these are all the possible combinations if 2 was added to one set, but if they were added to 1, then there are other combinations. So if 1 was added to the first one, it becomes 6, and if it was added to the second one, that would become 4 times 4. And then if 1 was added to the second one and then to the last one, it would become 5 times 5 stays the same, times 4 times 5, because 1 is added 3 makes 4, 1 is added 4 to make it 5. And then the last combination is if 1 was added to the first one and 1 was added to the last one, which is 6 times 3 times 5. So we need to find the greatest one of these. So we have to multiply all of these and find which one is the greatest. Well, at first, we can simplify this by crossing out all the duplicates. So this is duplicate of this, and this is a duplicate of this. Okay, so we do not need both of them. We just need to find the greatest one of them. And let's start by multiplying all of them. So first we'll start with this one. 4 times 3 is 12, times 7 is equal to 84, which is obviously probably not going to be the greatest one. Next one is 6 times 4 times 4. So 6 times 4 is 24, times 4, which is 96. So we'll write 84, 96. And then the next one is 5 times 5 times 4. So then 5 times 5 is 25, times 4 is equal to 100, which is the greatest of all of these, so we'll just cross these two out. And then next is 5 times 3 times 6, and 5 times 3 is 15, times 6 is equal to 90, and 100 is greater than 90, so the answer is 100. But we're not asked to find this, we're asked to find the additional license plates. So when you do 100 times minus 60, which is 40, so our answer is D, 40. Thank you for watching. If you really like this video, make sure to like and subscribe. If you have any questions, please say so in the comments, and stay tuned for the next video.